A product is only as effective as it is efficient and reliable. Imagine you are the product manager for an e-commerce app. There is a huge sale going on, and suddenly your app crashes because you had never taken into consideration the traffic of orders you would be receiving. A big fail. Now, this is a fairly common scenario where your app takes the user's credit card details and stores them. Are you 100% sure that the system is reliable enough to guarantee that no fraud can happen through it? AWS has provided a way to minimize these types of situations and make sure your product is efficient and reliable through the AWS Well-Architected Framework. AWS Well-Architected Framework helps you understand the pros and cons of decision making while building a system. What this means for you is that with this framework, you, alongside your solutions architect, can understand and learn architectural best practices for designing and operating reliable, secure, efficient, cost-effective, and sustainable systems in the cloud. Because we all know a well-architected system can significantly impact a business success. So let's get on with it. The Well-Architected Framework outlines essential concepts, guiding principles, and best practices for building and managing cloud workloads efficiently. The Well-Architected Framework is based on 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Let's move on with operational excellence. It provides guidance to help you apply best practices in the design, delivery, and maintenance of AWS workloads. Ask yourself, what is operational excellence? Your organization's leadership defines the business objectives, which guide the structure of work to achieve the desired outcomes. Your workload should generate valuable data to support these goals. Before going into production, it is your responsibility to assess and manage operational risks, ensure teams can effectively support the workload, utilize business and operational metrics to monitor performance and address issues that arise. Businesses evolve and priorities need reassessment. Therefore, processes should be continuously refined to drive ongoing improvement. To guide this process, there are 4 best practice areas for operational excellence in the cloud: organization, prepare, operate, and evolve. The design principles for operational excellence in the cloud include organizing teams around business outcomes, implementing observability, performing operations as code, annotating documentation, automating safely where possible, anticipating failure, and making frequent, small but reversible changes. To understand further, let's take an example of your DevOps team. They can use automation for infrastructure deployment. They employ infrastructure as code with AWS CloudFormation, ensuring consistent deployments, reducing human errors, and allowing quick rollbacks when issues arise. Moving on to security. The security pillar is the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. Before architecting a workload, you must implement security controls to manage access, detect incidents, protect systems, and ensure data integrity. A proper process for identifying and responding to security incidents must be in place to minimize risks. To ensure your users' data is protected, confidentiality and integrity measures must be implemented through encryption or other methods. In AWS, through the AWS Shared Responsibility model, you have secure infrastructure, so you can focus on securing applications and data. To know more about AWS Shared Responsibility model, you can check out my previous video. To ensure your security in the cloud, the best practices of the security pillar include security foundations, identity and access management, detection, infrastructure protection, data protection, incident response, and application security. The design principles for security in the cloud include implementing strong identity foundation, applying security at all levels, automating security best practices when possible, protecting data in transit and at rest, maintaining traceability, and keeping people away from data. To understand in more detail, let's take an example. A financial company handling sensitive customer data encrypts its databases using AWS KMS. They also implement AWS IAM roles to restrict access based on principle of least privilege, ensuring only authorized personnel can access critical resources. Now, let's talk about reliability. The reliability pillar encompasses the ability of a workload to perform its intended function correctly and consistently when expected. For a system to be reliable, you must start with the foundations. The architecture must be designed to prevent and mitigate disruptions such as misconfigurations or transient network issues. The workload must be able to seamlessly handle changes in requirements and detect failures. There must be recovery configurations in place so that the workload can heal itself after a disruption. The 4 best practice areas for reliability include foundations, workload architecture, change management, and failure management. There are 5 design principles to ensure reliability in cloud. They are: stop guessing capacity, recovery from failure should be automatic, test recovery procedures beforehand, dynamically acquire computing resources to meet demand, and manage changes through automation. For example, a global e-commerce website experiences fluctuating traffic. To handle surges during peak times, they utilize AWS auto-scaling, which dynamically adjusts computing resources based on demand. Additionally, they leverage AWS Route 53 for DNS failover, ensuring high availability across multiple regions. The 4th pillar of the AWS Well-Architected Framework is performance efficiency. Performance efficiency is the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demands changes and technologies evolve. Data is at the core of any business, so using this data to build your architecture is necessary. You must gather data on all aspects of the architecture, from the high-level design to the selection of resource types and even their configuration. The cloud is continuously evolving, so you must review your choices on a regular basis. Monitoring verifies that you are aware of any deviation from expected performance so that you can make trade-offs in your architecture. To ensure performance efficiency, the best practice areas include architecture selection, compute and hardware, data management, networking and content delivery, and process and culture. Evaluating the performance efficiency of your architecture includes experimenting more often, using serverless architecture, delegating where possible, and designing systems to be able to go global in minutes. Understanding with an example, a gaming company uses AWS Lambda for serverless computing, reducing latency and improving efficiency by automatically scaling based on incoming user requests. They also utilize Amazon CloudFront for content delivery, minimizing delay in gameplay. Moving on to cost optimization. Cost optimization refers to the ability to run systems to deliver business value at lowest price point. There are trade-offs in any type of product development, so it is with the well-architected framework. In the cost optimization pillar, we talk about trade-offs between speed to market and cost efficiency. Prioritizing speed can lead to over-provisioned deployments, especially when rushing to meet deadlines or launch new features. While this can result in inefficiencies, we know sometimes it is necessary, especially when performing a lift and shift migration from on-premises to the cloud. Optimization can happen later, but it must happen. To maintain long-term efficiency, the 5 best practice areas include practice cloud financial management, expenditure and users awareness, cost-effective resources, manage demand and supply of resources, and optimize over time. A well-planned cost optimization strategy ensures adherence to best practices, preventing unnecessary spending so that organizations can maximize the cloud's economic benefits. Cost optimization includes adopting a consumption model, analyzing and attributing expenditure, measuring overall efficiency, implementing cloud financial management, and using managed services to reduce the cost of ownership. A startup optimizes cloud cost by using AWS Savings Plan for predictable workloads, reserving instances ahead of time to save money. They also adopt AWS Trusted Advisor to analyze unused resources and right-sized instances, avoiding unnecessary expenses. By setting budgets leveraging AWS Budget, they can track their cloud cost and receive alerts if they have exceeded their usage plan. More on budgets in this video. Moving on to sustainability. The sustainability pillar focuses on environmental aspects, especially energy consumption and efficiency. Sustainability is the ability to continually improve sustainability impacts by reducing energy consumption and increasing efficiency across all components of a workload. These efforts can range from the initial selection of an efficient programming language, adoption of modern algorithms, use of efficient data storage techniques, deployment to correctly sized and efficient compute infrastructure, and minimizing requirements for high-powered end-user hardware. Hence, the best practice areas for sustainability in cloud include reason selection, alignment to demand, software and architecture, data, hardware and services, and process and culture. To facilitate good design for sustainability, you must understand your impact, establish sustainability goals, maximize utilization, anticipate and adopt new, more efficient hardware and software offerings, use managed services, and reduce the downstream impact of your cloud workloads. For example, a data-intensive company moves workloads to AWS Graviton processors, which are designed for energy efficiency. They also leverage Amazon S3 intelligent tiering, ensuring data is stored in cost-effective storage classes with minimal energy consumption. As mentioned earlier, workload design involves balancing and making trade-offs between these architectural pillars based on the business needs. These decisions help to guide and drive engineering priorities. Say, in a development environment, we may prioritize cost over reliability, while for mission-critical solutions, we often prioritize reliability at the expense of cost. For an e-commerce solution, we might want to focus on performance to ensure customer satisfaction since it directly impacts revenue. In common practice, security and operational excellence are generally not traded off against the other pillars. This is all for today. If you want to know more about the AWS Well-Architected Framework, you can go through the white papers in the description below. AWS even provides labs through which you can access workshops and hands-on labs to help you and your team learn, measure, and build the architectural best practices. I've linked it in the description. Also, if you want to know about the Well-Architected Tool, comment below and I'll bring it to you. If you like this video, give it a thumbs up and don't forget to share and subscribe. See you in the next video.